Okay, Trig Algebra 3, we are in section 2.4. Continuing on, this is the third part of this section. So today what we're going to do is take a look at some functions, some features of certain functions, and what they're going to look like when we graph them. And we're going to learn when we throw in numbers into them, how they transform or shift the functions. So we're going to first talk about these, and then we're going to go into transformations and see how adding numbers can shift them. Okay, so these are called parent functions here. These are functions whose vertex is through the origin at 0, 0, and do not have any shifts whatsoever. They don't have any numbers in the that cause shifts in the function itself. So it is going to be very useful to memorize these and keep our notes handy for when we go over the assignments with this. So the first one on the top left is called the identity function. That's y equals x. You guys have been learning that one since Algebra 1. That's the y equals mx plus b, straight line. Here the y-intercept is 0 and the slope is an invisible one. The next one is called, it says squaring function here, but we use the term quadratic function when you have y equals x squared, and that forms a parabola whose vertex is at the origin. The third one, the square root function, is y equals square root of x. That one we have not dealt with before. The fourth one is called the cubing function, y equals x to the power of 3. Cube root function, y equals the cube root of x. The reciprocal function, which actually has two sections to it, that's 1 divided by x. And the absolute value function, which you guys learned in Algebra 1. It is the one that forms a V opening up or down. So y equals absolute value of x. So when it says here, if you know the basic shapes of these graphs, you can graph similar functions using transformations, that is by shifting, stretching, shrinking, or reflecting the original. Remember, reflecting means flipping over, or also known as upside down in a way. All right, so here's some transformations, some more notes for us that we're going to be using today. So vertical and horizontal shifts. Vertical is up, down, left, and right. So that is these two guys here. Notice the plus b and minus b. B, of course, would be a number, kind of like the y-intercept in a way, in some cases. And when it's a plus a number at the end of a function, that's a shift up. When it's a function down, that would be a minus a number at the end. And there's also horizontal shifts. That would be left or right. Typically, notice how it shows here x plus d and x minus d in parentheses. So you will know if it's a horizontal shift, left or right, if there's a number in with the x within parentheses, or a radical, or an absolute value. Okay, and then reflections are really easy. This box here is a little confusing. I'll help you out when we get close to it. What it's essentially saying is the two scenarios where it would reflect over the x-axis, and the other scenario where it would reflect over the y-axis. We, in this lesson, are only going to deal with reflections across the x-axis, and that would appear when you have a negative sign right after the equal sign. All right, so very wordy here. Just be patient and bear with me. All right, so say if we took this parent function here, this would form the parabola just like we showed on the last page, y equals x squared. The origin would be here at 0, 0. Or sorry, the vertex would be at the origin 0, 0. Now, what if we took a function and we started throwing some numbers in? Notice x minus 2 is in parentheses. According to the notes up above right here, x minus a number in parentheses, means it would shift right. So that has a shift right of 2. And then notice right here, we have a +3 at the end. That would be this guy here. A +3 by itself at the end, so that would also shift up 3 units. So when somebody looks at this function here, they can see that it has 2 shifts. It shifts right 2, up 3. Right 2, up 3. Just like it says right here. And then we can just draw or sketch, do a little rough sketch of the parabola. So that's all we're doing here today, is we're doing some rough sketches, and we're going to be shifting around the vertex before we draw the shape. Okay, so what happens if you have a negative sign right after the equal sign? Well, let's slow down a bit here. We did say the last problem, this is a shift right 2 and up 3. So right 2 and up 3, and then we put a vertex. And then the negative sign right after an equal sign means it's a reflection. So notice on the graph here, instead of a parabola opening up, it's a parabola opening down, and we call that a reflection. Okay, so let's take a look. We're going to learn this best, not by me really reading stuff out to you. It's really by me showing you straight up how to do it. So let's get some examples down. So let's start off with A. We got x squared minus 6. Okay, what's an x squared look like? So what you would do during your homework is go back and go, it's that one, x squared. So it's going to look like a parabola. So if I'm going to give you a rough sketch of the parent function first. There's the parent function, x squared. So now in red, I'm going to draw the new one. The minus 6 means down 6. And then put your vertex, and then you can draw your sketch of your new parabola. Okay, let's take a look at the next one. So we have absolute value of x. Let me draw the original. So the original, according to the notes above, is the v. That's the parent function. Now let me draw the new one with the transformation. In the absolute value, I have x minus 4, so that's a shift right 4. So I go to the right 4, put my vertex, and I give my rough sketch. Okay, let's try another one. This one's one we're not familiar with. We haven't really used this one ever. Square root. Let's take a look back up here. What's the square root one look like? It's going to look like this one, the square root function. So I go down here. So the normal would be square root of x, which would be at the origin, and it kind of goes this way. And so, well, I have 2 shifts here. The first thing, when I say shift, by the way, I also mean transformation. I use both of those terms. The x plus 2 is in the square root. So that's a left or right. Which one would it be? It would be left 2. So I'm going to move my vertex left 2 and put a dot. And then also, this means we have a negative right after the equal sign. We learned on the previous page that that's a reflection. So instead of opening up like this, it's going to be not a straight line. It's going to look like this, okay? Actually, I made that look way too horizontal, so let me try that again. Something like that. All right, next up, we have another square root. So the parent is square root of x. Let me draw the parent first. So now, what are these two things? Well, x plus 2 we had on the previous problem. To the left, that was a left 2. And we get a minus 3. That's a number at the end of the function by itself. So remember, that's up or down. Since it's a minus 3, that would be down 3. So left 2, down 3. Left 2, down 3. And this one would open up just like the normal parent function would. Okay, so now we're going to transition. So again, when you guys hit up the homework, make sure you have this page available, and make sure you have this page available, especially the boxes here. Okay, so use this as a guide to help you through the homework, and you'll be golden. All right, so let's learn how to write new functions with listed transformations. So in example A here, it says we want to write a function that's in the shape of y equals x to the third, but it's going to be upside down and shifted left 5 units. So we're going to start off with y equals. Since it's upside down, that means reflection. So that means we put a minus sign or a negative sign right after the equal sign. And it's shifted left 5. Left 5. Remember, left or right means it needs to be grouped. If there's no parentheses here, which there's no parentheses here, so we have to make parentheses. And in that, we're going to put x plus 5. And then this exponent here, please make sure it appears. That is an important feature. So we need to also put that important feature in our new equation as well. So let's move on to B. This one is going to be in the shape of square root of x, but shifted right 6 and down 4. So right 6 would be x minus 6 in the square root. Again, you're going to refer to your notes when you go on your own. How do I know it's minus 6? It said right 6. So if you look up here, right 6 would be that. Notice it shows in parentheses, but we're not going to use parentheses because there's a square root there. So we're going to put that x minus 6 in the square root. And then down 4, again, I can refer back to my notes if I'm confused. And I go x minus, or down 4, that would be this. So we put a minus 4 at the end. All right, and then letter C, the shape of y equals square root of x, but shifted left 2 and up 8. So left 2, that would be x plus 2 in the absolute value. All right, not going to use parentheses because we have to have the absolute value there. If the absolute value is here, the absolute value feature has to be here. Okay, same thing with the last problem. If you got a square root here, you better have a square root in your new one. And then up 8, remember what I said, up or down is at the end. Up 8 is a plus 8. So pretty simple stuff here. We didn't have a lot of examples. You know, the lessons aren't typically that long. So what I just set you up to help you out with, actually I'm going to help you out a little bit more. So if we take a look at assignment 2.4b, I'm going to hit up a couple for you rather than have you do a dozen graphs. So if you take a look at the top left, number 51, people get confused on that one. So remember, if you look at it as y equals x, which is the parent function, that would be the one that looks like this guy. So if it shows minus 3, that's not grouped. This is not grouped in parentheses. So that means it must be down 3. So instead of the parent, so here's the parent function. Now let me draw the new function. So you go down 3. And there it is, x minus 3. Okay, let's go to number 60, an absolute value. So here's the parent, so y equals absolute value of x. Up in the notes, it shows that it's going to be that v for absolute value of x. So we have 2 changes here. First, we have this plus 2, so that's up 2. So go up 2 and put a dot. And then also be careful, we actually have a negative right after the equal sign. Remember, that's reflection. So instead of opening up, it's going to open down. Okay, number 61 is one you guys haven't seen yet. Let's take a look up. What's the x cubed look like? Right here on the top left of the screen. Okay, right here. So the parent, so it's y equals x cubed. So there's the parent function. Now let me draw the new one. X minus 2 is in parentheses. That means right 2. So right 2. And it's a reflection. Take a look. Right after the equal sign is a negative. So reflection, think upside down. So there it is. And that should set you up real good to finish that up. I hit up 3 more examples for you to help you out. So what I set you up for today is to be able to do assignment 2.4b. You'll be able to finish these graphs here. They only take a few seconds each. They don't take long. And then same thing here. These don't take long as well. All right, guys.